Hey everyone, hope everyone is doing well. So this is going to be another video in System Design Unleashed series, right? So if someone is new to the channel, this is the second video. Before this, I have uploaded this design Instagram in 20 minutes, right? And as we get started, right, just want to cover some of the things. So disclaimer, this is going to be a high level approach to the design problem, right? Focusing on quick revision and also the key concepts, right? For the like an optimal kind of a design, right? There is no best design, so that's why I'm not using the word best, right? There are always key trade-offs. So to my best of my knowledge, this is how I would be designing. Right, little bit about myself. I run this channel which generally talks about DSA and design. I have 2000 plus rated lead coding, and then currently work at Microsoft. And last year, when I went on a switch journey, I was fortunate enough to receive 10 job offers. And during those time only, I gave more than 20 high-level design interviews, and I was able to clear most of them. That's where I thought of creating this 20-minute series, which can serve as a quick revision for everyone, including myself, right? But let's say if you want to do a deep dive, you want to spend couple of hours and you want to learn everything like in detail, so you can go to this page. I'll attach the link in description and please feel free to go through these. There is a book by Alex Hugh. It is really good. I've read it like 5 to 10 times. And then this is also good. Hello Interview is also good. System Design by Code Carle is also good, right? So I myself has learned system design from all of these channels and plus some more, right? So with that, what I have basically done is when I was learning, I kind of created a compiled version of it, taking different things from different design and created a minimal version of it. Okay, so with that said, let's get started, right? So in this video, we are going to look at Twitter search, and you can call it Twitter, you can call it X. So if someone is not aware about it, so Twitter is a social media where one can create tweets, and these tweets can be filtered by search, by text, and also keywords, right? Whichever so now, before we get started, some notes, right? So as I have given a lot of interviews, one thing that I would like to highlight is in an interview setting, right? This is the flow that you would ideally follow, or based on your interview's feedback, you will discuss functional, non-functional, capacity estimation, database design, API design, high-level design, and all of those things, right? And then component deep dive. And then crisps, this is something that I always keep in short to remember. So crisp is like caching, replication, indexing, sharding, purging, right? So do you don't forget some basic concepts. Because in interview we are only 45 to 50 minutes, so we want to answer most of the questions. So this is some of the techniques that I came up with. Now in rapid system design, like the one that we will be doing, we only will be discussing functional, non-functional, high level and component deep dive, right? And then crisp, right? Because rest of the all things, I think these can be designed like once you learn for one design, these will be more or less same for all the other design, like mathematics and then entities also. Naming will change, but the schema and all keeps same. Now, who should watch this video? This would be benefit for any bachelor in anyone in bachelor's engineering student, and then also working professional and anyone preparing for interviews, right? And we are not going to use Elasticsearch for this. Elasticsearch will be out of box solution. We are not going to use anything like that, right? So with that said, I have already spent 3 to 4 minutes. Let's get started, right? So coming to the functional requirements, right? So in Twitter, user can create tweets, create and like tweets, right? And now user can sort those tweets by like or time, and user can search tweets by keyword, right? So these will be our main functional requirements. It could be given to you by interview, or you would have to kind of come up with them yourself. Now coming to non-functional, right? Now, in non-functional requirement, now if you don't know the meaning of these things, I would highly suggest you read a book by Alex Yu. He kind of explains all different things, but this is meant for like a quick revision and then quick dinner time video or like a Netflix series. So non-functional requirement. So this is like what your system should behave and like how scalable it should be, right? This is what the properties your system should have, and Now for non-functional requirements, right? Again, this is some concept that I have derived LCS plus DFS. This is a very popular data structures concept algorithms, longest common subsequence, depth first search, right? Using this only, I kind of form my non-functional requirement. So L stands for low latency. So in this system where we would need low latency, right? We would need it for search queries. So search should be fast, right? So the response time should be very less. C stands for cap theorem. So here, instead of failing the search, it is okay if we show the old results, right? So we would say that, okay, availability. Our each node in our distributed system does not need to have the latest answer, right? It is okay even if the data is little bit stale, but not much stale. Now coming to the scalability of the system. So this is again some numbers that I have just taken by reference from 500 million daily active users. This is the scalability. So you would have 100K tweets per second. All of this is per second, right? And then 100K likes, right? You could drive this from your daily active users, right? Again, then DFS is durability, fault tolerance, and security, right? So these all are always there in all of the systems, right? So I will be skipping that. With that, let's go to our high level design, right? So I'll move this to a side and then let's start. You should not worry by the design. I'll be taking you through each and every aspect of it, right? Don't worry about by looking at how he has already done the design. That's not, this is just so that I don't waste much time. So we'll be looking at each of the things one by one, right? So let's uh, take a laser pointer. So this is our client, right? So this is like you using the Twitter app, whether you are using it on a web portal or whether you are using it on your mobile phone, right? Now, the first operation that we discussed was that you can post tweet and post like, right? So for this, again, we would have a API gateway. API gateway helps in routing, authentication, rate limiting, everything. It is generally recommended in a microservice architecture. If you don't know about API gateway, read little bit more about it. It is a really important thing and also really interesting thing. Just like a traffic control system, right? Just like we have a traffic police and it is pointing the members or let's say people audience onto different roads. In the same way this also points them to different roads or microservices. So for this system we have only as of now two microservice or let's say one service, right, which is tweet service. So each tweet, this will be a post call. This is how it is going to look like. This will have some content, post call, and then we would have a load balancers. Load balancers will distribute the traffic to our tweet service, which is horizontally scaled, all the system design concepts, right? And then once you do this, right, and just FYI, this is not something that you should come up with an interview straightforward, right? This video is going to help. Let's say you have read this design earlier also, but you are keep forgetting, you're forgetting it. So this will be like quick revision. You can watch this on 2x and you can basically revise your design, or I can watch my videos, right? So, but that said, so this tweet service, right, it is like horizontally scalable. Now you would be storing your tweets in any databases, but I have like a logic abstracted because this is not the purpose of this. So let's say our tweet is there, right? Now in the same way, we would have like service. We would be storing our like in either in the same database or some other database we would have there. So both our like and tweet are sorted. Right now, how would you search? So the main important is that search by keyword, right? Let's say you want to search by Ronaldo. So all the tweets which have Ronaldo in it, right? Cristiano Ronaldo, right? Very famous footballer. So one of the good, right? But I do support Leo Messi, so not the best, but yeah, one of the best. Both are at same level. But yeah, coming back to the video. So in this, right? So now in this tweet service, let's say you have ton of tweets in this database, right? Naive approach would be that you run something like this. Select star from tweets where text like you search this keyword. So here you would be putting a Ronaldo. So if we have, let's say five, so every, we have 10K tweets coming per second, right? So for example, we have, let's say 500 million tweets per day. So we would be searching through all of that, which means that this query is very slow, right? So we should not use that, right? So we need to come up with a better approach. Now, for this better approach, what we are going to do is, right, we are going to have some sort of uh, indexes. So there is a concept which is called inverted index, right? It's a very popular concept. Even Elasticsearch uses it. So our design will be based on that only, right? One of the important aspect would be inverted index. Now, how inverted index works is, right? So let's say we have a index T1. So just focus on this injection service, right? Now, and then I'll come to this Kafka as well. So now in this, right, how inverted index works is, let's say you have tweets T1, T2, and T3, and then each of them has a Ronaldo in it, right? So we are going to create an inverted index on this Ronaldo keyword, and then all the list of tweets that has Ronaldo in it, right? That's how inverted index works. So basically, for all the words and the names in the tweet, we are not going to create this for is MR, right? So for example, you have is, you have R, right? We are not going to create for that. All the things that actually made sense, we are going to create this inverted indexes, right? And now why have put this Kafka here, right? I could have just made a API call, like this tweet service could have made a API call to this ingestion service, right? That would also happen. But do we really need to make that API call, right? Do we really need to put that load on this tweet service? No, we don't want to do that. That is why we want to bring in asynchronous thing between this, between these two services. So that's where Kafka comes into. So this is just a quiz. So what will happen is, right, this tweet service or this like service, it is going to put a event, right? So it is, so for tweet created, this would be the event structure. Let me zoom in. So just finish designing Twitter search. This is something that I have kept intentionally. And then you have this tweet liked also, right? So this would be the events that would be put into this Kafka such that this search ingestion service, right, this can take a look at it whenever they want, right? So it is already there in the event. The job of tweet service is done. These don't have to do anything else other than that, right? Now, once it is there in this Kafka, so this generally, right, the use of this is to create a buffer, right? So that's how I understand it. So if let's say if it was a API key, so this has to be always up and all, right? So but this kind of creates a buffer within it, right? Now you put it in a Kafka queue and then this will be read by the search ingestion service. Now, when the search ingestion service reads it, right, it has some tasks. So first task is that to create this inverted index, right? Now, and then we do have two requirements, right? We have requirements like by time and like. So we'll come to that later, but it has to create this inverted index, right? Now, where do we store this inverted index? It will not be like that. Okay, so whenever you are making a search for Naldo, we are not going to every time create this inverted index, right? That is not like, then you are wasting a lot of compute power, right? So we need to store it, right? Now, we can store it in different ways, but here what I would be doing is, right, I would be storing this in a Redis, right? So we would be using Redis. So Redis can eat. So this to me looks like a good use of sorted sets in Redis, right? So this is one of the thing that Redis provides. So that is what we are going to use, and this is going to be a distributed Redis. So that's why you see multiple Redis instances. If you don't know about Redis, so please read about Redis. But some of the things that I'll be touching upon. So Redis can store things like this in a sorted sets. So you have keyword which is Ronaldo and then all the tweets, right? So this could be sorted. So here we'll be sorting the tweets based on the time, and then we would also be sorting based on the like, as we discussed, right? So we could decide the parameter for this sorted set. So that is our search index, right? So basically now let's say if now let's talk about, right? So let's talk about how the search will be handled. So this I had to cover earlier because this will happen whenever a like or a tweet will be coming, right? So this the flow will be like this, right? But this, why I have kept it green is because these green things are important for this green search, right? If let's say there was no post tweet or post like, we would not really do none of this. So we don't really need to do this, right? Okay, so now coming to our search flow, how it is going to look like. So there will be a request coming to this API gateway. API gate will come to this search, and we will have a load balancer in front of this search read service. What it is going to look at is, let's say I'm searching for Naldo, right? Ronaldo. So when I'm searching for Ronaldo, it is going to look up in this Redis for this Ronaldo keyword, and then it is going to return all of the tweets of that Ronaldo, right? And then same for Leo Messi, same for any other person, Virat Kohli. We will do the same thing for Virat Kohli, right? So that would be our flow of it, right? Now, anyway, the right flow is this, right? This is just the read flow, so we don't need to worry about. Now, there could be asked that, okay, the whole process would take some time, right? Let's say it takes like 1 minute, right? Now, if this takes 1 minute, that is okay. Like that means that the tweet that just came in will not be coming out in this search, right? But okay, 1 minute is okay for like that's why we said that we are going to tackle available, we are going to prioritize availability over consistency. So that is the read, like that is how the your search would operate. But still, there are some of things that I would like to touch upon. Now, this is a distributed Redis, so this would be on a separate server, but this search would have its own server, right? So we would be storing like a most search query. Let's say Virat Kohli is very famous or it is trending, so we would keep trending in this cache. But then we would also need to worry about our cache invalidation strategies and whatnot, right? Like how we would remove the cache things from that, right? So those kind of things we need to worry about, right? Uh, then also different cache strategy, right? Which cache strategy you would use if your cache size is full. So these kind of things you should discuss with your interviewer. Okay, with that said, a couple of things there, right? Now, let's say everything is in memory, right? But about persistent, right? How we would be persisting the data. So one option that I read before creating this design or when I was doing deep dive was that there is an option for persistence in Redis, right? That option we could use, or we could also think of a DynamoDB kind of database, right? This is like a persistence storage, and then also it supports key value pair, right? This is key value pair database. So our search ingestion could go to this key value pair, right? That would be another option that we would have, right? And so that is all that. Right now, what about, let's just suppose that we go with this DynamoDB option. Now, in this, we would have to, now the data is huge, right? Let's say we have like millions of keys, right? Which is true. We would have like different words and we have millions of keys, right? Now, those millions of keys cannot come in, let's say, one server. We'll take an example. Now, ideally, Redis, so this is again something that I have read before creating this design, that Redis instance can handle up to 2 million keys, right? And even their set can handle up to 250 million keys, right? So ideally, even if I take million example, one server would be fine, and then we would have replicas. But I just want to like talk about another concept, which is sharding. So like if let's say this one server, right, one instance cannot handle, right? So we need to split our load, right? Let's say we have like tons of keys, we have billions of keys. We'll take example of billion, right? Billion of keys. Now, one instance of Redis cannot store that billion, right? So we need to shard the data. We need to partition the data basically. Now, how we would do that, right? One way would be that you can do it based on the keyword. So here, this search ingestion service, right? We would use a hash function there. So if it is Ronaldo, let's say we do a hash over it and then we put it to this, right? Then Messi, we do a hash over it. So hash would generate some number, right? And then it would go to this, right? And then same for this. Now, there is a concept of consistent hashing also that one should read about that also. But with keyword, right, there is one drawback which is called hot celebrity problem. So if you sort it based on Ronaldo, right, what is going to happen is, let's say everyone is querying about Ronaldo, right? There are a lot of tweets. There is 1 billion tweets all about Ronaldo, which is very much possible. So your this instance is going to go away. That's where you can um, shard it based on post ID and based on tweet ID. But now there is a drawback with that. Then you cannot straight away return this, right? Because now these are sharded based on your tweet ID, right? So then your Ronaldo tweets can be here also, here also, here also, right? So in that case, you would have to put a aggregator here, right? Now that aggregator would be there would be like a aggregator service, right? It's a concept again, one of the design trade-off that you would do, right? You would have an aggregator service, and then it would be reading all of from all of these, combining the result and then returning back. But for this, I would be going with the first option only, but I would just highlight that approach, right? So we have discussed about these two things. And then, so if we go back to our CRISP, right, we have talked about indexing. This is basically indexing. We have talked about replication. We have replicated the data. We have talked about sharding. We have sharded the data. And all the old posts, we can purge them, right? We can purge them. And then coming to one of the caching, right? So caching, we have already talked about caching, but one more another principle is CDN, right? This is a very popular concept. If let's say no one is not aware about CDN, so CDNs, although are costly, we can kind of make one decision that let's keep all the let's say very popular keywords or like very much queried keywords in a CDN and then return it directly from here. So we don't even need to go to these things, right? So that would be another approach. So CDN's full form is Content Delivery Network, and this is like a group of networks you can say which will be close to. If I am in India, if there is a CDN in Bengaluru, so my request will be returned from that. But if I'm in US and here this is in San Jose, it will be returned from that. Read about CDN, guys. So you should know about read CDN, right? So, okay, let's me see if I have uncovered everything. So yeah, that would be the design. That would be something that I would like watch before my design. So that's it for the design of Twitter, guys. Feel free to let me know in comments where I have made the mistake, where you think, okay, this doesn't make sense. This would not scale at all, right? Would be happy to learn, would be happy to improvise. Thank you so much. Have a nice day. Bye.